Okay, so this is question 9 from last year's term 1, periodic 1. So this is very similar to the types that we've been going over, these questions from last year's first periodic. So let's just continue here. So in this question, you've got a car with an initial velocity of 20 meters per second. I'm going to make a little picture of this to help me understand the situation. All right, so V naught, 20 meters per second. Then it slows down and it stops a little while later. So that means that V final is 0 meters per second. It also tells you that the distance it moved was 100 meters. So that is your displacement, delta x. All right. Also, we should get used to drawing a coordinate system for these problems. Here, very often, the origin of the coordinate system should coincide with the initial position of whatever the object is you're talking about. All right, so in this coordinate system, the positive direction is towards the right. It doesn't have to be. It depends on the problem. Okay, so then we're looking for, that's t. But the information we're given is V naught, which is 20 meters per second, and V final, 0, x, and delta x, which is 100 meters. So we're looking for t. So you would look through your list of equations. Okay, there are 4 of them. And decide which of those you could possibly use here to find time. And the equations ideally would have, these other 3 quantities. So we've got, let's see, how about V average is delta x over t. We also have V final is V naught plus AT. And we have about delta x is V naught t plus a half AT squared. And then there's always good old V final squared is V naught squared plus 2AX. And so initially it would seem like, oh man, there's just not enough information here, right? For example, in this question, we don't know what, actually this question doesn't even solve for t. We could use this to find the acceleration. So it turns out this is like a 2-step problem. You need to find out one variable and then use that to figure out what the final answer is. So let's check out this equation right here. So I know you're thinking, wait, we don't have V average, do we? Actually, you do. In this problem, it's easy to figure out what V average is. If we solve this for time, that's going to give us that time is equal to delta x over V average. Okay, so your delta x is 100 meters. The question is, what is your V average? Well, like I said, in this case, it's easy to figure that out. In all problems where the acceleration is uniform, well, average velocity, you just get that by averaging 2 velocities. All right, so the initial velocity is 20. Plus the final velocity, which is 0. And you divide it by 2. That's how you find the average of 2 numbers. You add them and divide by 2. So that gives me a V average of 10 meters per second. So then divide that by 10 meters per second. And so number-wise, 100 divided by 10 is 10. Dimension-wise, meters over meters cancel, and 1 over seconds is seconds. So there you go. So your time is 10 seconds. Problem done. Thank you very much.